Here we go. Hello, welcome to JW2542 Tutoring SHSAT Math course, online 2023 to 24, lesson number 6, scientific notation. This lesson is being live streamed on Twitch tonight, October 18th, 2023. And if you're listening to this, this is the recording on YouTube as well by Josh here on my channel, JSMWNYC. Thank you for joining me tonight. This is the Columbia Teachers College Zoom room that I reserved. And my name is Josh Wiener. I am an educator from New York City in mathematics, grades 5 to 12, and also college and graduate student mathematicians. Thanks for joining me here. Tonight, we're going to focus on scientific notation for 7th and 8th graders for middle school. And this is the lesson that's one of a series of 25 lessons that I will share for SHSAT prep. So it's a modular course, a workshop model that I'm doing online by donation to thank my viewers. To make the long story short, I spent many years after high school being a street performer, a juggler and musician, but took the money from my street performing and performing as an artist and went back to college, completed 2 college degrees, a double major, and then was accepted into Columbia University, where I finished a master's in math education in 2012. So I've been teaching math ever since, as for my profession, since 2012. So thanks for joining me. This is the course that I actually wrote, and as the SAT course is also free. I'm choosing to share them for free, and they go to greenhouses for between $1,500 and $2,000 per child. So welcome to lesson number 6. Here we go. All right. So to get things started with this specific class, remember that it is a free class. You can pay by donation to Venmo, Joshua Wiener 10. This is completely voluntary. I do recommend $50 per lesson. I'm giving you all the course content, quiz, classwork, and homework, as well as support videos on my YouTube channel. You don't have to pay anything at all. Pay what you think it's worth. And then you can use the files. The files will be open share. And this is for my development as an educator, and in the future, working towards publication of these classes into a book form or as online materials. So thank you so much. It's still a course evolving and in development. All right. Looking at the SHSAT mathematics exam itself, remember that the exam will focus on topics that are 7th and 8th, 5th through 8th grade algebra, geometry, coordinate plane, charts and graphs, probability and statistics, as well as a few other math topics. These topics are similar to number sense puzzles, problem-solving puzzles. That you could find the best resource is if your school has a math team or has students that compete in math contests that are citywide or statewide, such as the AMC 8 exam, or has puzzle books in their math library, such as Martin Gardner or Theoni Pappas or Dean Posmentier from CCNY. Those types of writers that are real collectors of the problem-solving skills that help deepen your understanding of our number world and number patterns and numbers that exist. Okay, so I do direct you to that. Those are sort of the seminal works for getting ready for problem-solving exams, such as the SHSAT. It has 75 minutes of test time in the math section. In its current form, it's still 57 questions total with 5 grading questions and 52 multiple choice. Tonight is lesson number 6, a focus on scientific notation. This is page 1 of the lesson. And this is one of 33 lessons that is sold to be used. I am actually the classroom teacher as well. So I lead the lessons 1 to 33, for example, in the long course, which is the entire school year, maybe once a week. Or if you'd like a summer intensive, 4 days a week, this packet of 33 lessons will serve you very well as a checklist for skills that your child will need in grades 8 and 9 to get ready for the SHSAT exam. We've already done number sense, exponents, and square roots. Tonight is lesson 6, since I actually added a new lesson, group-like terms, which was new for the 7th graders, according to the test results that we had from the last 10 years at this tutoring house. So this is now lesson number 6. Excuse me. Before we get to the lesson on scientific notation and a few model problems on how to add, subtract, multiply, and divide with scientific notation, we're going to do just like we do at the tutoring house. We're going to start with our warm-up quiz. Students come into the classroom, or they come to the online classroom or pod class, sit down, and we begin with a 10-minute warm-up quiz. The quiz is here as a Google form link. And oops, I should have had this ready for you guys to put in chat. Sorry, I need to go through the motions here, so to speak. So I'm also off screen here on another computer screen, and I'm going to open up the forms we're going to use tonight. The quiz is here. Can I overlay it just for a moment? Here's the quiz. And what I'm going to do now is extract a link for you. And I'll put the link in the class chat window. So, and if you click on this blue form link, which I'm overlaying here, then it will take you to the quiz. Notice the code is a little bit different, the way they generate it each time they regenerate it, but it's the same form link. And this link will be active, this blue one here, oops, that ends with KCRN 9, right? That's quiz number 6. Tonight, it's 5 questions in 10 minutes. But also, if you click on the chat, if you join the room here, you can go to quiz number 6. So I'm going to mute and pause here. So once you go to the quiz, if you're watching the YouTube video, I'm starting my timer for the quiz. You have 10 minutes for these 5 practice questions. After completing the questions with your pad and paper, make your selections on the bubble sheet below in the form and click the blue submit button, and the school computer will auto-grade it for you. So good luck tonight on quiz number 6, 2 easy level, 2 mid, and 2 challenge level questions. And I will see you guys in 10 minutes. Please begin now. I'll see you in 10 minutes. Good luck. 2 more minutes on tonight's SHSAT quiz number 6. 2 more minutes. All right, please finish the problem that you're working on and make sure you can answer for all 5 questions. That is time for SHSAT quiz number 6. The next thing we'll do is we'll, in service to you, go over a way of solving each problems 1, 2, 3, 4, and 5 in less than 2 minutes. Starting with question number 1. Question number 1 reads, Anna buys bananas for her banana bread that she sells at a local bistro. Bananas cost 59 cents per pound. She needs 2 pounds of bananas per loaf of bread. How much is Anna's cost to make 8 loaves of bread? Okay, so we have, in terms of dollars and cents, 59 cents is the cost of her bananas per pound. But, oh, where's the other parentheses? But, let me use yellow chalk. You have to multiply that by 2 pounds, and that would be 1 loaf. But we're going to multiply that as well by 8 because she's making 8 loaves. So let's figure out the best way to do this so that we don't make a mistake. Whoops, where'd the pen go? All right, so what I'm going to do is I'm going to multiply this times this first. That's $1.18 or 1.18. And then I'll multiply it by 8 because then I'm just multiplying by a single digit. 8 times 8 is 64. Put down the 4, carry the 6. 8 times 1 is 8, plus 6 is 14. Put down the 4, carry the 1. 8 times 1 is 8, plus 1 is 9. Then remember, be careful to move in 2 decimal places because of the first number. And the correct answer is $9.44. The correct answer was A. Next problem. Question 2. A square lot has an area of 30 square meters. What I'm going to do is I'm going to put 2 perfect squares here, one that's larger and one that's smaller. So you get the idea. If the area of the square lot is 30 square centimeters, what's the best estimate for the side length of the lot? So if the area is 30, It's one of these 5 answers, A, B, C, D, or E. Work with what you know. You know that, okay, if I'm going to space out here a square, and on the side, I put, okay, we're going to design a square, 4 on this side. Whoops, excuse me, 5 on this side and 5 on this side. And then we know that the area is base times height, length times width, right? So it's 5 times 5 is 25. So the area of this square is 25. We're going to do the same thing over here with a larger square. Here, I'm going to space out a square, but it's from our lesson on square roots. Put 6 on this side and 6 on this side. The area of this larger square, 6 by 6, 6 times 6 is 36 area. So now we know that, well, we might not know the number that belongs on the side length of the square in the middle, but we do know that to make it a square that has area of exactly 30, whatever numbers on the side that we have to go with, well, that number for the square root of 30 has to be between what 2 numbers? It has to be some number between 5 and 6, right? Because we know that if we use 5 times 5 is 25. If we use 6 times 6 is 36. So look at the list. What's the side length? Well, it can't be 15. 15 times 15 is over 100. It can't be 10.95. 10 times 10 is also over 100. 7 times 7 is 49. That would have an area of at least 49. And there, D must be a possibility. Then look at E. Well, if we round up 3, a square that has side length 3 times 3 is 9. So the only reasonable answer from the choices given is the side length or number that goes here and also goes here has to be D, 5.48. And remember, this is an estimate, right? We can check that by multiplying it. 5.48 times 5.48. Or we could do 5.5 times 5.5 just to save a little time to make sure that it's close to an estimate of 30. Here we go. I'll just do the 5.5. 5 times 5 is 25. Carry the 2. 27. 275, right? Then put a placeholder down. Or put a utensil like over a plate. And then it's got to be the same 3 numbers, 275, because we're also multiplying a 5. Right? 275 must be seen again here because we had a 5 in the ones place and 5 in the tens place. Add the columns. Just be careful when you do this. 5, 2, carry the 1, 9, 0, carry the 1, 3025, 3025. No, we have to have 1 decimal place, 2 decimal places, 1, 2, string it below with this streamer. 30.25. So that's a quick estimate. That's pretty close to 30. It's just a little bit over, but we round it up. So 5.48, we're confirming it here just by plugging in. That is a good estimate to the nearest 100 for an area of a lot of 30 units squared. Meters squared, because it was meters. 30 meters, so 5.485. That's about the size of a school classroom, right? 15 feet by 15 feet, 17, yeah, like a small classroom. Okay, very good. Question 3, on to the mid-level. Compute the sum and write in scientific notation. All right, well, we have 3.29 times 10 squared. And again, to do this quickly, I'll scribble it out. 3.29. Whoa, well, maybe I can write it. 3.29 times 10 squared. And the other measurement is 7.14 times 10 squared. All right, so I'll put the exponents up here. So if we write it in scientific notation, we know that we're counting in the hundreds because it's that 10 squared is 100. So this is some number multiple of the hundreds. 7.14 times the hundreds. So any good scientist reads the number quickly, that whatever we're measuring could be It could be a distance, it could be a weight, it could be an amount of time, but this is the hundreds. Right? You know this from math class, right? 10 squared, 10 times 10 is 100. All right. So now what we do is, if you want to write it in standard form, is that number 2 are the number of decimal places we move to the right. So we're going to move 2 places to the right. For this measurement, we're going to move 2 places to the right. And then we can write equivalently in standard form. So the same number in standard form, 3.29 times 10 squared, is 329. 7.14 times 10 squared, moving the decimal 2 places to the right, 714. The writer said, can you add those two measurements together? 329 plus 714 will give us that sum. Here we go. 7 plus 4 is 3, carrying the 1. 1 plus 2 is 3 plus 1 is 4. 3 plus 7 is 10. So we get 1,043. Okay. Well, now we have to move that number into scientific notation, to some with a power of 10 attached to it. But be careful, because here we have 10 squared and another 10 squared, but this has more than 3 digits. This has 4 digits now. And sure enough, when you move the decimal properly into scientific notation, we have to move it 3 places to the left. So 1.043 is correct. And then the power of 10, well, we moved it 3 places to the left, so the exponent is 3. So the correct answer is, in scientific notation, this measurement is 1.043 times 10 to the 3. We're now in the thousands, a little more than 1,000, in other words. And the only correct way of scribing that is choice C, 1.043 times 10 to the 3rd. Correct answer was C. All right, next one, number 4. 3 consecutive even numbers add up to 78. What is the largest of these 3 numbers? Okay, so it's 3 numbers. Consecutive means in a row. And to help you navigate this, let's pretend we had the number ribbon like your teacher puts on the board. We're pretending it's a never-ending storyline for you, right? That's the idea in math, right? So we're going to join this line. We're scanning it mentally, and we're looking for 3 even numbers in a row that add up to 78. So just what comes to mind is, well, what if we start at 20, right? And then the next number would be, the next even number would be 2 more. That's 22. The next one would be 24. The next number would be on the line would be 26, 28, and so on. And then, well, what if we said, well, we want 3 in a row. So what if we try these 3, 20, 22, and 24? Well, we could, but adding them together, I would just add the 20s. We have 20 plus 20 plus 20. I'm adding the tens column. And then 0 plus 2 plus 4. So quickly, that's 60 because of the 3 20s. And the 1's digits is 6. So it's 66. Well, we want the sum to be 78. They want to add up to 78. So I know that I'm going back and forth on the line, but if we start at 20, that's too small. So we have to start, we can't start at 20. That's incorrect. So we have to start at a number larger than 20 to get 3 in a row, right? So you can do this by guess and check. Just to give you another example, we could start at 30, right? Then the next number will be 32. Then the next number will be 34. So what if I said, okay, all right, 20 was too little, so why don't we try 30? And then we'll go with those 3 numbers in a row, 30, 32, and 34. Then same thing. I'm going to add the 3 numbers together and see if they equal 78. Okay, I'm just going to add the 10s here, 30, 30, 30. 30 plus 30 plus 30 is 90. Too much. I don't even have to add 0 plus 2 plus 4, but if I did, that's a plus 6 again. That's 96. So that's wrong too, because it's too big. So at least we have it trapped, so to speak, just like with that square root of 30. As if we go back, that's wrong because that's too small. That's wrong, so it's too big. So we want three numbers in a row. It's got to start with 22, 24, 26, or 28, right? So you can do it that way and then work like an engineer. Just dive right into the number line. Based on the clues, I think it's got to be somewhere in this area here, some number between 20 and 30. We're going to go back to this number line in just a moment. But when we solve problems like this, and since you're in 7th or 8th grade, we use it systematically using algebra notation. So it doesn't matter where we start. We could start, but we could, because we have three in a row. Here, notice that the three in a row were 20, 22, and 24. Wait, I have the wrong color chalk. 20, 22, and 24, a block of three numbers. Here's a block of three numbers, 30, 32, and 34. Well, what if I wanted to put that into the language of algebra, and I'll use the middle number here, right? I'll call that middle number x. Then since even numbers skip by 2, like 2, 4, 6, 8, 10, 12, right? The number to the right is that x plus 2. In other words, if x is the placeholder, if x is 22, then the number to the right is 24, but that's 22 plus 2, right? Am I making sense? Right, that's the next number. The number before 22, if 22 is x, the number before is x minus 2. All right, so I'll write it in here. Just be careful. Here I'm using white chalk. All right. Oh, and we're going to add them together. And they have to equal 78 total. Remember, it didn't work when we started with 20. If x, meaning that the middle number is the one we're going to place here, right? So be careful. If I say, okay, 22 is the middle number, that's our x, then we'll get the set 20, 22, and 24, right? I'm just representing it with algebra now. Equal 78? No, right? If we do it also for 32, if 32 is x, then the one before will be 30 and the one after will be 34. So what we did when we were sort of guessing, like the story here was that it was too small. The story over here, oh yeah, those summed up and it was too big. So let's solve it algebraically. All right. And then that's the whole point of setting up as an algebraic equation. X plus x plus x is then 3x. Minus 2 plus 2. Just grouping like terms on the left side. Notice that the 2 and 2 cancel. So we get 3x equals 78. And dividing by 3, x equals 26. So by solving it using the system of balancing and rebalancing called algebra, right? We divide both sides by 3, divide this side by 3 and this side by 3. We get 1x is 26. Sorry, skip that step. I didn't write it out, but I'm writing it out now. 3x is 78, so divide the left by 3, divide the right by 3. 1x is then 26. So now we have the middle number. We have it solved. But remember, if x is 26, that means that 26 is the middle number of the group, just like that was the middle number and that was the middle number. So for the three numbers from least to greatest, we then have these three numbers. 26 is the middle one. And the one to the right would be two more. 28 is the largest. The correct answer was A. We can check this pretty easily because we're just adding three consecutive numbers. Once you have the right answer, well, we have to just add them together. Here, I'll do that on the right side or way over here. So we have 24 plus 26 plus 28. Well, 4 plus 6 is 10, plus 8 is 18, carry 20, 40, 60, 78, and that is correct. Okay. But by using this system of notation of algebra, we can systematically find where we needed to navigate and be like, oh, let's see, if we use 26 as the middle number, then the three numbers in a row will add up to 78. All right, last one for tonight. Spend a little extra time on that. We're going to have a full lesson on consecutive integer puzzles later on in the course. Next one. Question 5. Play clay comes in 4 colors: rosy red, marine blue, army green, and clementine orange. So I'm going to use capital letters here. R for rosy red, B for marine blue, G for army green, and O for clementine orange, RBGO. You can only pick 2 colors for an art project. How many unique color combinations are there? Well, this is our set that we're starting with. The writer says that we have like a bin of crayons. This is the box of crayons. There's only 4 crayons. Are they crayons? Play clay. Oh, excuse me. There's only 4 types of clay in the box, in the clay box. You can get red clay. I'm gonna do it like this. There's some red clay. There's blue clay. There's green clay in the box. Wait, that wasn't blue. This is blue. And there's orange clay. So you go over there and you walk over to the clay box and you can pick any 2 colors to make for your art project. How many combinations are there? What we're going to do to solve this is we're going to write out the sample space. This really helps with probability, knowing sample spaces. And we're going to do the sample space for this set, meaning we're going to do all the combinations. All right. So how do we do all the combinations without missing any? Well, we have a pick. We can pick red, for the first color, or we're picking the first color. We can pick blue. There's 4 ways we can pick blue. We could pick green, or we could pick orange. Then we're going to make our second pick. So for the second pick, going with red, blue, green, orange. So now I'm going across. Here I went across red, blue, green, orange. But now for the second pick, I go red, blue, green, orange going in this direction. Okay, this will give us all of the combinations in one array or in one rectangle of written code. Red, blue, green, orange, right? Starting with green for the first pick, the second pick could be red, blue, green, orange. And for the third pick, the first pick is orange. The second pick could be red, blue, green, or orange. The writer says you can pick 2 colors for the art project, meaning 2 different colors. All right, students have argued with me about this, I'm like, technically they should write it like that, but we mean 2 different colors. So red, we can eliminate. That's not going to be a combination. We can't pick blue, blue. We can't pick green, green, because that's the same color as one color. We can't pick orange, orange. Notice if we go across the diagonal here and cross those off, those are the only ones where the color is repeated. Okay, but those ones are eliminated because we're picking 2 colors. Right, if the teacher said, go to the clay box, you can only pick 1 color, right? There would only be 4 solutions: red, blue, green, or orange. All right, since you're picking 2 different colors, go to the first row, right? We pick red can be combined with blue, green, or orange. Those are 3 different combinations. Now, we have all the combinations that start with red. So then we can eliminate this one and this one and this one because we already have blue, red. We already have blue, red. That's right there. We already have green, red. That's right there. We already have orange, red. So you don't want to double count those 3. You see what I'm saying? Those are the same ones in reverse order, right? So those ones also get eliminated, these ones here, because we've already counted them here. Red, blue, red, green, and red, orange. Oh, wait, right? Red, blue, red, green, and red, orange. So since this first one is eliminated, because all three of these are now eliminated, we now look at blue. Well, it can't be blue red because we already have red blue. It can't be blue blue. So we have blue can go to green and blue can go to orange for our color combinations. Notice that the same thing happens on the other side of the diagonal. Maybe I should draw the diagonal like a wall. Draw it like a wall. Right? See, that's a wall of the sample space, the mathematical wall, so to speak, right? The long diagonal. Here we have blue-green, so believe it or not, that'll eliminate blue-green. Green-blue is the same combo. BO is the same as OB, just you picked orange first, then you picked blue. So also we would eliminate these two from the sample space. I'll put them in a red box. Those are eliminated. But these ones we just counted, so 5 so far. Next, green red has already been eliminated. Green blue is eliminated. We can't have green green because it's the same color. So green will go to orange. We haven't had that combination yet. Notice that GO is the same as OG. So get rid of OG. But GO will stay. No, wrong color. Not right. GO. So the correct answer was 1, 2, 3, 4, 5, 6. There are 6 unique color combinations because we have to eliminate the double count. No double counts. Right? So we can't double count. These are all the double counts. These ones that I'm crossing off with a white line. Blue red is the same as red blue. Green and orange are the same as these 3. Green blue and orange blue are the same as these 3 in reverse. And OG is eliminated because it's the same as that one there. There are 6 unique color combinations for the art project. The end. All right, I hope you enjoyed this review of our warm-up quiz. That was the challenge level problem for SHSAT middle school students. All right, now at this point in the video, we're going to go to the core lesson. Tonight, our focus is on scientific notation in mathematics for middle school students. And this is the first page of the lesson. Each lesson in my class is a 1 to 4 page mini lesson, and then a set of 30 practice problems for SHSAT. So what we'll do first is we'll review the basic idea. So scientific notation is the focus for tonight. STEM fields are exciting careers in the 21st century. STEM stands for science, technology, engineering, and mathematics related work. Would you like to be a doctor or become a computer scientist and design computers and programs? Or a civil engineer and work with architects to build bridges and skyscrapers? Would you like to explore new ideas and tackle ancient unsolved problems as a mathematician? All STEM workers are fluent in scientific notation. Scientific notation is a compact way of representing very large or very small measurements. Large measurements include the distances between stars and planets, moons and asteroids, galaxies and superclusters. These measurements are represented with positive exponents, large measurements. A scientist working with an astronaut at NASA must be very precise with large measurements, often to 10 or more decimal places in calculations. Telescopes aid in improving these calculations based on human observation. So we're going to start with positive exponents first and add and subtract. Whoops, I'll get back to this slide in just a second. I didn't crop it correctly. For the first example, it's like the one we had for the warm-up quiz. So it's a little predictive. 5.3 times 10 to the 4th, right? And I went over the fact that, oh yeah, wherever the decimal is in place, we would have to move it that number of places to the right, that number of places to the right. So for the first measurement, it's 4 places to the right, and in expanded form, that's 53,000. In other words, the 10 to the 4th is in the 10,000s, and we have 5.3 of those 10,000s, or 53,000. Here we also have a number measurement in the 10,000s, 10 to the 4th. It's 2.8 times 10,000, or 28,000. Adding them in standard form might be easier, so we get 81,000. Then remember, to do this right, you have to pack it back up into science notation. So move it 4 places to the left, and the decimal's in the right location, and we have the right exponent, 8.1 times 10 to the 4th. Okay, so notice that we didn't have enough. We didn't have to get to the next power level, the 5th power, because we didn't make it up to 100, right? So the leading coefficient now is 8.1 times 10 to the 4th. Here's an example with subtraction. We have 6.2 times 10 cubed minus 5.1 times 10 squared. Remember that we have to expand using the exponent above, 3 places for this measurement, and 2 places the decimal will move for this measurement. Okay, just like this one was 4 and 4, 3 places means that it's 6,200. 2 places means that it moved 2 places. We add 1 0 here. It's 510. Yeah, that you have to remember that you write out the zeros as needed. Okay, 6,200 minus 510. We have to do on the side. Here, I'll write this one out. 6,200 minus 510. Well, 0 minus 0 is 0. 1 is bigger than 0, so cross this off, make it a 10. I'm going to make it a 1. And now we're borrowing 10. 10 tens is 100. So one of those hundreds becomes 10 tens. 10 minus 1 is 9. 5 is bigger than 1. Cross off the 6, make it a 5. This is now an 11. 11 minus 5 is 6. And 5 in the thousands place. So we get 5,690. Remember what we do then next. We move the decimal in 3 places. So it's really 5.690 times 10 cubed. And now that 0 placeholder can be crossed off. And it's 5.69 times 10 to the 3rd power. Next, we're going to look at small measurements. Okay, those were positive exponents. However, we can also use this, scientists use this notation for small measurements or things seen under a microscope. And they're represented with negative exponents. You're going to work with computers. Computers are designed smaller and smaller. The capacitors used to, like a computer used to fill up a whole room or warehouse. It's a very large machine. But now, since they're designed smaller and smaller, parts on your smartphone are measured even now in micrometers and nanometers. We have medical instruments and computer parts. We have factory-built machinery of any kind made with precise measurements. The permitted error for these parts so that they all fit together is called the tolerance. Let's look at an example with negative exponents as well. So here we have addition and subtraction. Remember, we're doing all 4 of the operations. When we add and subtract, we have 2.5 times 10 to the negative 2. And we have 7.6 times 10 to the negative 2. So writing this out, 2.5 times 10 to the negative 2, 7.6 times 10 to the negative 2. We'll get, moving the decimal 2 to the left, 0.025 and plus 0.076. So instead of moving the decimal to the right, when you have a negative exponent, you have to negative 2, move it 2 places to the left. So we need to write in the placeholder. There, the placeholder 0. And for this number as well, we have to write in the placeholder 0. So we get, it's less than 1. These are very small things like seen under a microscope. It's only 0.25 meters. Here's only 0.076 meters. I said that wrong. 0.025 meters and 0.076 meters. Now we add them together. 5 plus 6 is 11. Carry the 1. 1 plus 2 is 3 plus 7 is 10. Put down the 0. Carry the 1. And we also have one in the hundreds place. Okay. So we have 101, and don't forget that the decimal is here. So it's 0.101, or 101 thousandths is absolutely correct. For the last step, we need to put the decimal back into scientific notation behind the first number here. So you have to move it now one place back to the right. So we write this as 1.01 times 10 to the negative 1. That's the number less than 1. 10 to the negative 1 is the same as 1/10, right? So 1.01 times 10 to the negative 1 meters is correct. For the next problem here, we can see that we do have a number that is, maybe I should save this. Has a very large negative exponent. Looks like it's in nanometers. We have 9.5 times 10 to the negative 9 minus 7.1 times 10 to the negative 9. And I'm going to write this on the screen. This is a good one to go over. Because we have 9.5 times 10 to the negative 9, and we have 7.1, and we're subtracting 7.1 times 10 to the negative 9. We could sit there and move the decimal 9 places to the left. Right? That's what we do when we see the exponent is negative 9. That means we have to pick up the exponent, move it 9 places to the left. Pick up the exponent, move it 9 places to the left. Right? But we don't have to do that. We don't have to rewrite it as 0.0000095, 0.0000071, because they're the same exponent, right? As long as we don't have to borrow, we're still at the same, we'll be in the same, the decimal points will line up. Maybe I should write it out, right? It'll be, yeah, let me write it out. What we're saying is that this is 0.04567. And I'll put it in threes with a little space so we can see it. 7. It's 9 places to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And this one, 0.000000071. That's what the number is. It's in nanometers. It's 95 nanometers. But we properly moved the decimal from here 9 places to the left. Moved it 9 places to the left, right? This looks ridiculous, but we're just subtracting zeros anyway. When we subtract, we're going to get 0.000000000. We have to do the ones for 5 minus 1 is 4, and 9 minus 7 is 2. So we're going to get this number, 0.000000024. Then we'll properly have to go with the decimal behind the first non-zero number. So it belongs there. And our answer is, it's equal to 2.4 times 10 to the, well, we moved it back 9 places, right? Because we still had 10, a number in the tens in the ones column, that's why. So 2.4, we're still at 10 to the negative 9. So in other words, use your good judgment. Since this is 10 to the 9 and this is 10 to the 9, and we're subtracting and we're going to still have something in the tens and ones, you can just leave the that's not going to change the power of 10. It'll still be 10 to the negative 9. But 5 minus 1 is 4, and 9 minus 7 is 2. And you can just subtract the coefficient as long as you're not changing the power level. It's not less than 0, right? Or so you have to borrow, and that would change the exponent. It's the same exponent, because it's just 9.5 minus 7.1, and the exponent does not change, right? These are all placeholder zeros. These are all placeholder zeros. And in the final answer, 2.4. Oops, let me just shade it with a different number, different color. 95, 71 is now 24. The new coefficient is now 2.4, but the exponents stay the same. Okay. All right, so that was add and subtract. The multiplying, dividing exponents, we multiplied the coefficients together and then add the exponents. And I'll explain by highlighting that here. Question number 1, example number 1, a grain of sand weighs 1 times 10 to the negative 6 grams. And researchers at the University of Hawaii estimate there are 7.5 times 10 to the 18 grains of sand in the world. There it is. So how much do all the grains of sand in the world weigh? You take the weight for 1 gram and multiply it by the approximate count of all the grains of sand on planet Earth. So we have to, that's 1 grain of sand times all the grains will be the total weight. Okay, so notice that we have 1 times 10 to the negative 6, which is the same as 0.0000001. And then we're multiplying that by 7.5 times 10 to the 18. So that number that we're multiplying it by is 7.5, oops, 7.5. Oh, that's 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's this humongous number, right? It was here, so that's 2 plus 15 is 17, plus 1 is 18 digits to the right. So those are the same numbers written in expanded form. So we're literally multiplying this by this. However, what you do is you multiply the coefficients separately using group-like terms. So we really have just 1 times 7.5 instead, which is 7.5. That's the coefficient. And then the powers of 10 work like this. 10 to the 18 is 10 to the 18. But if you have 10 to the negative 6, you can put that in the denominator as 10 to the positive 6. Right? That's what a negative exponent is the same as 1 over 10 to the negative 6 is the same as 1 over 10 to the 6th power. And we went over that with positive and negative exponents. So this measurement literally is 10 to the 18 over 10 to the 6th. And using the subtraction rule for division, that's 10 to the 18 minus 6. In other words, it's 10 to the 12. So you do the coefficients separately, just multiply them, and then multiply or divide the, we're actually multiplying, but remember you add the exponents together. Negative 6 plus 18 is the same as 18 minus 6, which is 10 to the 12th. And the final answer is, the coefficient is 7.5, but the power level is 10 to the 12th power. So the weight of all the sand in the world is 7.5 times 10 to the 12th, or 7.5 trillion grams. Last example with multiply and divide. In 2012, the population of China was about 1.351 times 10 to the 9 billion, or 10 to the 9 or billion. And the population of Japan was 1.276 times 10 to the 8. Based on these estimates, how many more people lived in China than in Japan in 2012? Write your answer in scientific notation. Well, again, recapping this idea, we have to take the coefficients, 1.351, and we're dividing it by 1.276. And then we take the powers of 10 and handle those separately. So we're actually dividing 10 to the 9th by 10 to the 8th using the subtraction rule for fractions. Here it is written as a modern fraction. It should make more sense now. Then we get this. Notice that 1.3 is a little bigger than 1.2. And we get 1.05877 for the coefficient times 10 to the 9 minus 8. Right? Because when we're dividing, just like in the previous problem, we subtract the exponents. If you set it up as a fraction, 9 minus 8 is 1. So 1.5 times 10 to the 1, or that's actually equal to a little more than 10 times the population. Right? Because 10 to the 1 is 10. So moving the decimal, that would be correct. In other words, in 2012, for every one person in Japan, there are more than 10 people in China. There's more than 10 times the number of people in that country. All right, so that's an introduction to multiply and divide with scientific notation. All right, and those would be the challenge level problems for this level of testing for middle school students. So let's get to the classwork. Remember that it's arranged with the first 2 pages being easy level 1 to 12, 13 to 18 are mid-level, and the challenge level are 19 to 24. Then it's followed by 6 review questions, easy, mid, and challenge level that are grid-in. So as is tradition with this course, we're going to do, it's 30 questions, but since it's a 90-minute class, we're going to do even problems only for the classwork. So here's the form link to SHSAT classwork number 6. And I'll also, as is tradition, put it in the class chat window here for any participants. If you're on Zoom, you can pause the video and cut and paste this form link. I'll also put it in the comment section below when I have time to edit the video. Okay, so you'll see the link to, it'll be an open share of this course for 2023. So you'll see it also in the comments below. Right here it is in the chat window, so you guys can get to work. So please begin SHSAT classwork number 6. You have 20 minutes of independent work. If you like, you can go scroll the video ahead, and after the 20 minutes practice, we'll go over a few select problems, 1 easy, 1 mid, and 1 challenge level to review this class, and then we'll wrap up for tonight. So good luck on this independent practice of scientific notation. I'll see you in 20 minutes. Yeah, 3 more minutes on tonight's practice of scientific notation. 3 more minutes on tonight's 20-minute practice of classwork number 6. Even numbers only. 3 more minutes. Okay, ladies and gentlemen, please finish the problem that you're working on and make sure you have an answer for all 15 questions. That is time for SHSAT classwork number 6. I'll give you just a few moments to submit your final answers, and the computer should auto-grade it for you. If you entered the Google form, make sure that you enter your name and email address. And if you click on the button down at the bottom of the form, we'll give you an extra copy sent directly to your email address with the question set, as well as solutions to the problems. What I'm going to do next is I'm going to put the solutions to the classwork, as is tradition, on the board for you to study with. These are the questions that you practice with, so that when you go and do the homework for the week or for the next class, that you have done problems that are similar, so that you have best practice for the homework assignment, which also is 30 questions. Give me just a moment, I'll be right with you. And just have to verifying the solution key here, and in the editor off screen. And this one's a problem. Okay, that makes sense. Okay. All right, so what I need to do is I'm just going to X out of the slideshow just for a second and refresh it. And here we go with classwork number 6. It's done for tonight. All right, so in the interest of time, I will quickly read the solution set to SHSAT classwork number 6, our practice and focus on scientific notation. Here we go. It was even problems only. So question number 2 was B, 4 was C, 6 was E, 8 was C, 10 was B, 12 was B, 14 was B, 16 was C, 18 was C, 20 was C, 22 was A, 24 was B, 26 was 1.55, 28 was 18, and question 30 was 17, the age problem. All right, let's go through just to wrap up for tonight. One easy 1 minute and one challenge level question. How about that? I'll do that for you. So sorry, we're going a little bit over time here, but hope you're enjoying the class. It's a 90-minute class. Here we go. Question number 2. The basics of scientific notation. What we're going to do here is, which of the following is 340.5 in scientific notation? So we have a measurement of 340.5 units. Remember that in scientific notation, you move the decimal so it's behind a lead number. Right here, that'll be 3. So we need to rewrite it as 3.405. Well, how many places did we move it to the left? It was 2. So we need 2 powers of 10. That's when we adjusted the coefficient. So 3.045 times 10 squared is correct. The correct answer for question number 2, was B. The correct answer in scientific notation, the same measurement, is 3.405 times 10 squared. Or scientists could say to a coworker, 3.045 hundreds. Question number 3, which of the following, oh no, we're doing evens only. Question number 4, here's a division problem that's easier than the word problems we did. If we have 8 times 10 to the 8th, and we're going to divide by 4 times 10 to the 6th. Stack it as a modern fraction. And then you can see here that it's just 8 divided by 4 for the coefficients. And remember that when you do the powers of 10, we're going to subtract the exponents here, and 8 will become 6. So solving this question, 8 divided by 4 is 2. And for the powers of 10, that'll be 10 to the 8 are up above, but it's eliminated by 6 on the bottom. So 6 of those powers of 10 will be canceled off by factor canceling. And we get 2 times 10 squared. The correct answer was, let's see, 2 is the coefficient, so it has to be this one. Choice C, 2 times 10 squared. For question number 4, division in scientific notation. So we take 2 times 10 to the 2nd, or 2 hundredths. Question number 6, 720,500 divided by 100. Okay, let's write this out. 720,500 divided by 100. Well, you should know from middle school that you can cross off 2 zeros top and bottom. So we get 7,205. But remember, we're writing as a scientist, so we're going to pack it up, put the decimal over here behind the 7, and we get 7.205 times 10 to the, well, we moved it 1, 2, 3 places to the left, so 10 cubed. So as a scientist, 7.205 times 10 cubed. Where is that up above? Is that a typo? Oh, no, here it is. Choice E. E like excellent. So read it as 7.205 times 10 to the 3rd, or You'd say 7.205 thousandths. Going to the mid-level problems, number 12. Which is a multiple of 8? This one's not that hard. No, this is easy level. We're going to mid-level. 14, 16. 16 is a 5-second problem, and I'll show you why. If you look at the problem, you see it's 3.3 times 2.5, but all of the answers are 8, 2, 5 in some order, right? And then you simply have to look at the powers. So it's 10 to the 5th times 10 to the 2nd, so 5 plus 2 is 7. So it has to be one of these 10 to the 7th if it's in scientific notation. And it has to be this one, right? Because 3 times 2 is 6. So if that's the right triple digit, 8.25, that has to be the right exponent. The only reasonable answer is choice C. Okay, C is correct because that's the right coefficient, and that's the right power of 10. 8.25 times 10 to the 7th, or we could say 8.25 10 millions. What weird thing to say. It's 82,500,000, right? 8.25 10 millions. All right, let's keep going. That's precisely correct. Which of the following numbers is the closest product of 48.9 times 21.2? This goes back to our first lessons on estimating. Let's rewrite that as, well, that's close to 50, rounding to the nearest 10. That we're rounding up. This one we're going to round down to 20. So since we rounded one up and round down, we're going to get a pretty good estimate. That's 50 times 20, which is the same as 5 times 10 times 2 times 10. 10 times 10 is 100. 10 times 100 is 1,000. And the correct answer is C. C is the quick estimate. It's about 1,000. 10 times 100, right? 50 times 20. All right. That was question number 18. Going to the challenge level questions. Ooh, 20 is tricky, but 22 is even trickier. Let's go to 22. All right, 22 is easier. This one, very few students got in class. And I've been offering this one from an actual old SAT for maybe 10 years. It's been included in the lesson. I'm going to have to rewrite it so it's original before our publication, but this is one of the hardest questions on a previous SAT. I'm going to rewrite it as a fraction, 2/5 to the negative 2. All right, and then 0.6 is 3/5. 6/10 or 3/5, the negative 2. The next thing I'm going to do is you needed to know that, well, if you have the negative exponent, that's the same as 1 over 2 to the 5th to the positive 2. But more importantly, we can flip that one upside down instead. In other words, we can, instead of writing it that way, we're going to write it as 5 upon 2 to the positive 2, because that's the reciprocal rule. Similarly, for the denominator, 5/3 squared. For the next step, we're going to square the top and bottom, which we know from squares and square roots. 25 over 4 is stacked over 25 over 9. That's the same as 25 over 4 times the reciprocal 9 over 25. And lo and behold, the factors cancel. They both become 1. 1 times 9 is 9. 4 times 1 is 4. And the correct answer is 9/4, which was A, 2.25. 9/4 is the same as choice A, 2.25. So the new math for 7th graders are like, teacher never told us negative exponents. Well, you can switch negative to positive by doing the reciprocal. That's the first thing you need to know. Flip the fraction upside down. And then go with the positive exponent. Now we can square the top and square the bottom. And we're also doing the same thing in the denominator. It's a It's a negative exponent. How do we do negative exponents? We're going to switch it to a positive. Use the reciprocal. 3/5 becomes 5/3. Then what can we can square it now? 5 squared is 25. 3 squared is 9. And then, like if the teacher gave you this problem, then maybe 78% of the students would have gotten it. Okay, because of the negative exponents, that's what made it difficult for students. Okay. All right, so there you go. All right, going to the grid and review. Last ones for tonight. 26 is easy level. 28 is just a triple plug-in. I'm not going to go over that one. Just be precise. You know how to do a square root. Number 30 was a clever age puzzle. So let's do this one. And I'll make a little info chart for Miriam and Charles. So Miriam, I think that was Moses' sister in the Old Testament, the Bible, from my college studies. And Charles, so Charles, is 11 years older than Charles. All right, so we'll put C for Charles. Wait, use yellow chalk. And put C for Charles. Excuse me. Capital C. And then Miriam is 11 years older. So she's Charles plus 11. And this is now in time. Or present. So presently, Charles is C and Miriam is C plus 11. In 3 years, so all right, plus 3 years on the left, over the next row. All right, so then we have facts that right now, Miriam is 11 years older than Charles. But in 3 years, she'll be twice as old as Charles will be then. Well, in 3 years, whatever Charles' age is now, you're going to add 3 to it. And whatever Miriam's age is, we're going to add 3 to it, Charles plus 14. But the mathematical statement was she's twice as old. So how do we set up an equation? Well, Miriam now, she's twice the age of Charles in the future at C plus 3. So if we double Charles's age then in 3 years, in other words, we set up 2 times Charles plus 3 years is equal to, will be in balance with, well, her age then, she'll be Charles plus 14. All right, so that's how we set up the equation to solve. I'll put it in a box. Right? Her age in the future will be, sorry, I usually use blue when I set up a formula. Charles plus 14 is twice Charles plus 3 years. Now we need to solve that equation. So here we go. So Charles plus 14, equals 2 times Charles plus 3. First thing we need to do is distribute the 2 on Charles's side. Charles plus 14 equals 2C plus 6. Subtract 6 from both sides. Subtract 6 from the left. Or we can do any of the 4 operations on the left and right side of the equal sign. So then Charles equals, oh wait, no. 14 minus 6 is not 0, it's 8. Charles plus 8 equals 3 times Charles's age. Right? Should be twice as old as Charles will be then. That is wrong because that should say 2C, excuse me. Let me fix that. Why I put 3? I don't know. I'm only human. Please stay with me, fellow humans. Please stay with me, fellow humans. All right. So now I corrected the error. I just put a black card down and wrote it in white. 2C is the new balance. C plus 8 is 2C. Subtract C from both sides. Minus C, minus C. And we get the new balance of 8 equals Charles's age. All right, so we've now solved Charles's age. He was an 8-year-old child. That means that if Miriam is 11 years older, if he's 8, that's correct, plus 11, she's 19. So now we have both their ages now. Charles is 8. Oops. Charles is 8. And Miriam is 11 years older. She is 19. But the question was, how old was Miriam? If you put 19 down, you got tricked. Then you lost the point for the test. Remember to subtract 2. Miriam's not 19 yet. She's only 17, guys. So 17 was correct. 19 was incorrect. Make sure you go back and read the STEM question. It was not how old is Miriam now, but how old was she 2 years ago? All right, that was the end of this classwork practice with a bit of wordplay there, challenging age puzzle with Miriam and Charles. The end. Okay. So we're going to stop for tonight. Again, this was classwork number 6, a focus on scientific notation. Thank you so much for joining me tonight. And if you're watching this recording on YouTube, remember all of these lessons are free online. If you can, please support and donate this course in development at Venmo, Joshua Wiener 10. And you'll see that the content is still evolving. And for publication, I'm going to update all of them to original questions, which is, again, a time-consuming process, but this serves the course as well in tutoring houses in Brooklyn. Okay, at least 80% of the problems I've written based on research and the algorithms that students will learn, the formulas that they'll use in high school and in college, and from my studies in graduate school as mathematicians. So I hope that you enjoyed this course and understand that it's set up for vertical scaling for learning. All right, there's the key. If you'd like to learn more about me as an educator, I've been doing this since graduating graduate school in 2012. I have worked with for over 15 years, thousands of students, preparing them for New York State regions, the SHSAT, the test for Catholic schools, the cooperative exam, high school placement test, the PSAT, the SAT, the ACT, for AP exams in math, chemistry, physics, statistics, and calculus, for the graduate record exam at the end of college. Additionally, my students have gone down to nursing school, medical school, law school. They've gone on to graduate school and business programs as well. So it's been a very interesting journey working with students from grades 5 up to 12, and also college and graduate school as they do their standardized tests. I have parent praise here also on my Wix website, JW2542 on Wix.com. And you can read there if you'd like to hire me as a personal tutor. You can email me at jsmw2542@gmail.com or at the address shared and phone number shared on the screen. These are the links to tonight's lesson number 6. Again, they will be free and open share forum. If you'd like to try the quiz yourself, the classwork again and the homework, I'm sharing these for free online. The next class will be October 25th, next Wednesday, 2023 at 7 p.m. Eastern Standard Time. Thank you so much for your kind attention, and I hope you enjoyed this online class share. I hope you enjoyed this online class share. This is number 6 of 25 lessons. Maybe I'll see you next week. Have a peaceful week, and remember, happy studying. Okay, bye-bye. Thank you. Good night.